So this next part, we're going to look at getting an enumerator. So the enumerator is used to read the data in a collection, but not modifying the collection. So you might have noticed this, you know, when you're in a loop, you can't modify a collection while you are in an enumerated loop, because then the enumerator loses track of where it belongs. You know, if you're counting something and in the middle of when you're counting it, somebody takes a few things away or adds a few more things, then you're going to lose count. So that's the idea here, is that it's read-only in a for each loop. So the enumerator starts out being positioned before the first element. So at an index of -1, if we're thinking of it numerically. We have the reset method that we have to write that brings the enumerator back to that position. And enumerators are pretty simple. Basically, you know, we have the pointer, a way to move to the next element, and a way to reset it back to the beginning. If we want to run a for each loop on our custom list, then we need to write that enumerator class. We need to specify where to start, how to move, and when to stop. So we write another class for this purpose that implements the IEnumerator interface. So we're going to write a specialized class that implements IEnumerator that works especially for our custom list. So in order for us to write the enumerator class, we need to write the following properties and methods. Current returns a pointer to the current element. You might notice that I've kind of adopted that terminology when we're moving through our list in those while and for loops that I wrote. I always start with, you know, making a pointer to the current element. Dispose is used to kill the enumerator. We don't need to worry about implementing that. We're going to let C# kill it for us. Move next, pretty self-explanatory, and obviously reset, go back to the beginning. Now the enumerator is optional. It's not part of iCollection. You don't have to write it. But if you want to use for each loops over your list, then you have to write it. You don't have to use for each loop. So you can use a while loop and use the .next pointers. You know, the downside of that is it exposes the inner workings of your list. So if we think about how we want to access our custom list object, like from our program, if I wanted to write out every element, the only way right now that I can get to every element is by using these .next pointers and moving through the list. What I would rather be able to do is something like this. It just gives us access to each item one at a time. I don't have to worry about the pointers. I don't have to worry about counting, anything like that, right? We just want to be able to use for each, because for each obscures the movement between elements, right? Now, in our custom list class, we have two methods for getEnumerator. So we have IEnumerator typesafe and also the more generic version. So both of those right now are not implemented. What I'm going to do is I'm going to write a custom object for the enumerator. I'm going to put the class right in our custom list class. So I'm nesting the classes on purpose so that this class is available uniquely for each instance of custom list. I call it custom list enumerator. I know it's a real deep name, right? And it's going to inherit from IEnumerator. I'm going to make it type safe. So when we implement IEnumerator, I can choose to implement the interface through this. And you can see what it is going to create. So there's our current pointer, both the type safe and the generic object version. And then we have those three methods: dispose, move next, and reset. Now, I'm not going to bother anything with dispose. I'm just going to leave it blank. Move next is going to be going to the next element in the list, and then reset resets the numerator back to the beginning. So what we need in order to do that is we're going to need 3 references, all private. The list that we're going through, we can call it whatever we like. This is a reference to the list that we're currently moving through. When we make an object of this type of class, we're going to pass the current list. So the parameter is going to be this. I'm doing air quotes. This meaning this current instance of the list. So we'll see that when I call on this after it's created. We need an index. This is used to count or move through the list. It keeps track of our position in the list at any given time and the current item. The point of an enumerator is to return all the items one at a time. So just like any other class, we need a constructor. When we set this up, we've got 3 things. We're going to pass in a reference to the list. That we're going to assign this field. Index is going to start at -1. Remember from the slide, it has to start before the first element. The first element is 0. So the starting point of the index before we move through the list is -1. And set current to null because before we start moving through the list, the current element is nothing. Now the next thing that we need, you can see what we need here by mousing over. It'll tell us what we're missing from the interface. We need that public property to return the current element, both type safe and generic. Okay, so let's write those. We're going to write it as read-only. You can spread this out if you prefer looking at it that way. There's our item object. The other one is a generic object. Both of them return the same thing. So if you are looking for an item or if you're just looking for an object, both of them are going to return the current item that we're looking at. Now I want to make sure that, I can't stress this enough, it's read-only. You can't modify those directly from elsewhere. What else do we need? Let's see. There's 3 methods. We could just click this too. If you click on implement interface, it writes the methods and things for you. It's kind of handy. This one, I'm just going to comment this out. I suppose we don't need to worry about it doing anything right now. Now, move next. This tells us how to move through the list. So we're going to start by incrementing our index. That's the counter of the element we're looking at. Remember, it started at -1. So the very first thing we need to do is say, okay, we're going to increment that. We're going to go to element 0. Now, if we increment to any element and we've moved past the end of the list, then move next needs to return false. When you can't move to the next element, and you return false because move next is a Boolean. So true if you can move to the next element, and false if you're past the end of the collection. So how can we tell if we're past the end of the collection? Well, if the index is bigger than the number of elements we have, or even equal to, because remember the index is 0 to 4 if we have 5 elements. So we're looking for out of bounds here. If the index is too big, now we have the reference to our list and how many elements are in it. If the index is greater than or equal to that, then we return false. Otherwise, we have to pick out which element is current. So just like before when we were trying to count up all the elements and pick out one, we're going to move continually, index number of times to the next one. So this has shades of what we were doing before. I'm going to scroll back up, take a look up here. When we were writing our item operator and we wanted to say get to element 5, we did a for loop that just moves ahead 5 times. We're going to write the same sort of for loop in here that moves ahead index times. So I'm going to start at the beginning. Use cur to represent my current pointer. And we're going to start at the beginning of the list. This is the beauty of having the class defined inside the custom list class. I can access those private variables. If I had defined it outside, I wouldn't be able to access that. That's why we define the class inside the other class. So we're going to start at first. We're going to move through the list. And just go next, next, next until we get to the number that we want. Once I've moved ahead far enough, I'm going to do this. The temporary one is now the current. Now current, remember, is our field here. That's what the enumerator is going to return when we call on current. It returns this guy here. And if we successfully were able to assign that, return true. So move next works very similar to that item operator, and it's because they have similar reasons for existing, right? Both of them are intended to count your way through and move to a particular element in a particular position in the list. So we're counting positions in both cases, and that's why I used a for loop, because we have an upper bound to count to. Now what about reset? Reset is easy. All we need to do is move the index back for the start of the list. So this little class here will allow us now to do a for each loop. Now that it's done, I'm able to do that. Now, what did I call the list? Actually, I don't think I created the list. I did, I commented it out. There we go. We've got some items that we created. I'm going to comment out all of our code from last time so that we can add some new elements to our list. There we go. So if I add some items, looks like brown. Go go in the right place. There we go. I dot toString. Can't remember if we overrode toString last time or not. So let's take a look. Yep. So now that I have that enumerator, my list items here, I can use a for each, and it should move ahead in order. Now the order that I've added items, I'm just going to grab this and move it down lower so that everything is together. Added Z, then B, then R, then G. So Z got added first, but then when we add B, B will become first because that's the way that our add method works. So they'll show up actually kind of looking like they're in reverse order. It should say G, R, B, Z. Missing a bracket somewhere? Oh, thank you. How did I not notice that? And how did it work before? Oh, I had commented it out, that's why. Oh, we've got a error somewhere. Right, I forgot a step. This is why we test often, point out all the steps that we need. But you can see how this is being called, so I'm actually glad that happened. That when I try to do the for each, inside custom list, it went here. And let's see, I'm going to test this out before I say it. If I say var here, I think it will go to the other one. Nope, still goes to the other one. Maybe this one is if you do object. But you can see how it's trying to go to this get enumerator method in my custom list class. When it sees a for each, this is where it goes. But because of this not implemented exception, it doesn't understand yet how to go through. So this is the last step of doing the enumerator, is you have to make these two methods implement our custom list enumerator class. So this thing returns an enumerator object. Excuse me. So I'm going to return a new custom list enumerator. And this is calling the constructor of that. So when we call the constructor of that, we need to pass a reference to a custom list. So we're going to pass this. And I'm going to do the same thing here. There we go. So our enumerators, when we try to do a for each, it's going to go into the custom list enumerator class that we wrote. And we're going to pass it the current existing copy of the list. No, it's not a copy, it's the reference to the list. And then, you know, it starts at -1, and then we end up going through all of the things in this class in order to be able to enumerate. Here we go. So there's our list that works now with the for each loop. And it created that output. Okay, so let's go back. We've got time. We can look at CopyTo. CopyTo is used to copy your list to an array. CopyTo is one of the methods that is a part of iCollection. So if we look at, I'm in the wrong class here, custom list, when I implemented iCollection, one of the methods that we had to implement was called CopyTo. I'm just going to minimize the rest of these so I don't have to scroll so far every time. So here's CopyTo. This is the only one that we haven't done yet. So we've got all the rest of these objects. So CopyTo makes a shallow copy into an array. So the array of type item, this is the destination, and the array index indicates where in that array we start copying. So the array index that comes in, you know, if we have a list, say, of 5 items, and they have an existing array that has a length of 10, but the first 5 are already filled with something else, they can pass it in and say, you know, starting at index 5, copy this list into that array. So this is the starting point. So it's actually pretty easy to do, but the things that cause problems, of course, as always, the edge cases, the exceptions. What if you use it wrong? So we have to deal with all of those too. Now, if we look at CopyTo, the exceptions that could happen are argument null exception, argument out of range exception, and a generic argument exception. Okay, so some of the things that can go wrong. What if the array that they pass in doesn't exist? Or what if the array that they pass in isn't big enough? Or what if the array that they pass in, you know, our array index is out of bounds, for example. You know, if they try to say start copying at array position -3, you know, that's an issue as well. So we can throw those exceptions when you know, the call doesn't work out. So let's get some of those edge cases. If array is null, and we're going to throw argument null exception. With argument null exception, we can provide a message telling them which argument was null. Let's do that. Let's see what else. What happens if the array index is out of bounds? Oops. That's an argument out of range. What are some of the other cases? What if we don't have enough space at the end of the array? Well, how do we know if we have enough space? Because it's not just about the array size, it's also about the array index that they want to start at. If they give us an array that has 5 spots in it, but they say start copying at index 4, and you know, I have 5 items in my list, then it's still not going to work. The array is big enough, but the array index prevents us from using, you know, what comes before. If you're not sure what I mean by that, let me know. I'll try to explain it further. I don't want to harp on it, but I also don't want anybody to be like, what now? Okay, I'll move along then. So we're not just going to check the length of the array. We're going to check the length of the array that they gave us permission to use. So what I'm looking at is the array length minus the array index. For goodness sake, spell it right. So if this value, you know, say that the array is 5 elements long, but they want to start at position 3, so really we've only got 2 spots to work with, right? That's what I'm talking about here. So if the amount of spots we have to work with is smaller than our count value, so how many elements do we have, then this is going to be an error. And we're going to throw an exception for it. It's not about null arguments, it's not about out of range arguments, so the only other option that we can do here is just argument exception. And the message for this, what can we say? Insufficient space in array. How about that? Close enough. Okay, so that solves all the problem cases. What about actually if we want to do it right? We want to take each element and put it into the array starting at this position. Now, we can use a for loop, we can use a while loop. The way that we've been doing this up until this point, for the most part, we've kind of been moving back and forth between a while loop and a for loop. So let's do something like this. I'll start with a while loop and then I'll show you the for loop and you can decide what you like better. It's the same loop I keep writing over and over again, a while loop that starts at the first element and continues to the next element as long as the next element isn't null. So what do we want to do with the current element? We want to assign it to the array at that particular index. And then we need to move up to the next array index. So if you want to start at position 5, you assign to 5, and then you need to move up to 6. So the way that this works is assign that element into the array, go to the next array position, and this one is go to the next element in list. So that works. It makes a copy to that array. That's pretty much all we need to do here. So that's the way to do it with the while loop. If you want to use a for loop, the for loop is a little bit shorter because of all of the motion is kind of handled by the for loop header. I'm going to start at 0 up to however many elements we have. And inside the for loop, I'm going to assign to the array at that particular array index plus I. So I don't have to change the array index if I keep adding I every time because I is being incremented. So the array index can stay, or we could change it so that our for loop starts at that array index and moves up, continuing as long as we're less than count plus array index. But I find this is a little bit easier to understand. That way, if the array index is 0, then it won't affect and we'll just move from 0 and up. If the array index is higher, we'll use that as a starting point. But what are we assigning to? A reference to the element at a particular position. Well, without the current pointer, how can I assign? Well, think back to 2 hours ago when we learned about how to go to an element at a particular position. Because I wrote that item operator, I can go to this, meaning this current instance of the list, at position I. So we'll start at the first element in the list, and then we would go to the second one at position 1, and the third one at position 2, and so on and so forth. So this way, actually we don't even need these brackets anymore. You can see it's a little bit shorter to write. But if we look at how the item operator works, you still do have to move current equals current.next. It's just that we already wrote it there. So rather than reinvent the wheel and rewrite the while loop or the for loop, this way we already did it. So that makes use of something that we already wrote rather than writing more new code. So I think this way is a little bit nicer, but if the other way makes sense to you more, you are free to use whatever suits you best. Okay, so now at this point, our custom list class is completely done. just zoom out on it a bit. So we've got our private reference to the first element in the list. We have our item operator that allows us to index into the list through an integer. So we're able to do something like this. My list at 2, for example. And give us that index. That's what uses the item operator. So we've finished that. We have a count that allows us to know how many items are in the list. And we wrote add last week that indicates how to add elements. Now this version of add just puts the new elements in at the beginning of the list. So they make the new one the first every time. When you write yours in Lab 2, your add, well, it's called NQ because it's a queue, but it's going to be more complicated because the biggest task of Lab 2 is to figure out how to place elements in the right place. Now, I foreshadowed that a bit in our remove method, talking about how to remove items, and you have the same thing with add, where you need to make sure that you're getting it in the right place, and that means if you move too far, then you're going to have a hard time inserting. So if I want to put an element here, but I've already, I assess this one, okay, it needs to go after this one, and I assess that one and say, uh-oh, it needs to go before. There is no before, right? So remember, don't move too far past the place where you're going to have to update your pointers. So that's my hint for your NQ method in Lab 2 is don't move past the element that comes before what you're trying to insert. Okay, let's see, what else? We wrote contains last time, making use of that equals. And we wrote clear, which is a no-brainer. We just say, okay, if first is null, we lose everything else. It'll get collected eventually by the garbage collector. We wrote CopyTo, which allows us to make a shallow copy into an array. And here we have the enumerator. And notice that the class for the enumerator is placed inside the custom list class. There's two reasons. The first of all, that this object only works with custom list anyway, so there's no point in making it available anywhere else. And B, we want access to those private variables like first, and we can't get them from anywhere else unless we're inside, so put it inside the class. And then these two get enumerators return a new instance of this. And then we worked on remove. So I think that gives you guys everything you need in order to be able to do your Lab 2. When we come back from the break, we're going to look at some more topics, operator overloading, and the other topic. Its name escapes me right now. Let me look here. Oh, yes, abstract data types. So abstract, I forgot it existed. All right, so yeah, you've got some time to work on your lab. The next test isn't for a while yet. It'll be on the 12th of November is when the next test is coming up. So you've got basically 3 weeks from now to finish up your Lab 2. Let me think here. I'm going to extend that due date because there's only one more lab after that. And I think if you guys want some extra time, I'm going to make that happen. There's no need to make it due at the same time when the test is due. We can do that after. Okay, so anybody have any questions, concerns, thoughts? Okay, well, I hope you guys really enjoy your reading week, that you take some much needed rest time. And I will see you guys in 2 weeks. Thank you. Make sure that you don't leave your Lab 2 until the end. get started on it sooner rather than later. All right. Have a great week, everybody.